All right, and our last part for today is based on uncertainty in measurement. So if you took a class in high school, you might have talked about things called significant figures. We are definitely going to be talking about this today and how to make correct measurements. Chemistry is all about making measurements. Can you get the amount of stuff that you want to make in the lab? Can you measure the density? Can you identify what the substance is based on measurements? So measurements are extremely important in chemistry. So we have to make sure from the get-go you're measuring correctly. Okay. So first of all, there's two words that you need to know the difference between and what they mean. And those are precision and accuracy. Now, yes, we want to be both precise and accurate in our classes, in our labs. Sometimes that's not always the case. You may not be able to affect the precision from which you are doing things, but we want to be both. Okay, so precision in one word means consistency. The more precise you are, the more consistent you are. So we want very precise tools. If I'm measuring a block on a scale over and over and over, I should get the same answer over and over and over. If I'm not, it is not a very precise scale. Okay, accuracy is how correct you are. So if you actually get close to the value you are supposed to, hopefully we can be accurate. Sometimes we can't actually guarantee that we are going to be accurate, but we want to compare with what we are supposed to get. If you are very accurate, you're going to have a very low percent error. So you got the correct answer. Okay. All right. So if you look at, I like using these examples to determine the difference between precision and accuracy. If you look at these three dartboards, okay, this guy over here might be pretty good if we're not actually shooting for the bullseye. He's very precise. He's hitting the same spot every single time. That's usually what you're going to see from our instrumentation in the lab. It's pretty precise, which is great. But it's not accurate. No, so we're talking about if he was aiming at the bullseye. He's not hitting the correct spot. He's just very close. Now this guy is precise and accurate. He's hitting close to the same spot every time, and it's going where it is supposed to. Now this guy on the end is just terrible at darts. He is neither precise nor accurate. Okay, they are not close together. They are not near the bullseye. Now notice I don't have one on here that says accurate, not precise. You can't actually be accurate unless you are also precise, because if you don't have consistent data, you don't have enough data to actually say that you are accurate. So you cannot be accurate, but not precise. Okay, so I have an example here. It says, consider the results of 3 students who repeatedly weighed a lead block known to have a true mass of 10 grams. Okay, so on these graphs here, I've indicated by the solid horizontal line where 10 grams is. That's what they should have gotten. Okay, that is our theoretical value. A comment on their accuracy and precision. So take a minute to look at this data, see if you can see who was precise, who was accurate, who was both. Okay, so if I am looking at these, and the graphs I think tell a little bit better. This guy, that does not look like very precise data, right? It's kind of all over the place. It got really high, got really low. It's got a high standard deviation, which would indicate he's not very precise. Now remember, I said you can't be accurate if you're not precise. So he's not accurate either. Yes, the average is 10.13. It's not that close to 10. So this guy would be considered neither. Okay, if you're looking at student B, these are all very close together. Okay, all of their measurements are around 9.8, which is great. He's very precise. Maybe his scale is off a little bit, but he's not accurate because he's not that close to 10.00, which is what he's supposed to get. Okay, so I want you to be very precise in the lab. Hopefully that also means we are going to be accurate, but precision is something you can actually control. Okay. Student C is, of course, both. All of his measurements are really close together, and he got 10.01, which is very close, has a very low percent error compared to what he should have got, which was 10.00 grams.